In this lesson, we are talking about the total number of outcomes of a situation. So if relating it, let's say like to probability, um, so we're coming up with almost as if it's like the denominator of the probability, right? Like what's the probability of rolling a six-sided die two times, right? And getting a three. So we would say, well, the first probability would be 1 out of 6, right? Then we would multiply that by the second roll, getting a 3 would be 1 out of 6, which means then how many total outcomes could there be in this case? The 6 times 6, which is 36. That's the total number of outcomes, right? Then there's only 1 out of the 36 chance that you roll the 3 two times in a row. What we're talking about now is just focusing on like here. What is the total number of outcomes of a situation? So like here, we figured out the 36. So there's other ways though of figuring out the total number of outcomes. Like here, we're going to focus on like what's called the factorial. So factorial is shown with this 5 and exclamation point. This just represents taking that number and the product of all the values below it. So 5 factorial would be 5 times 4 times 3 times 2 times 1, which is 120. So 5 factorial is this here. So when we're talking about also the total number of outcomes, but then let's say there's grouping involved. So it could be a permutation or a combination. Like you have 5 people, in a group, or you have 5 people, 5 friends. How many ways can you make 2 groups out of your friends, right? You're making groups out of the total number of items. So there's what's called the permutation or the combination. So if I have this 5p2 here, this means that there are 5 total items and we're making the groups of 2. But here's the thing about permutation and combination. Permutation is without repetition and order matters. That's the key. Order matters with the permutation. It is very specific. Now, to set this up though, we would have 5 factorial over, then subtract 5 minus 2 factorial. So really, this is 5 factorial divided by 3 factorial. So when we solve these, 5 factorial, remember, right? That's 5 times 4 times 3 times 2 times 1. Then we're dividing by 3 factorial. Well, that is 3 times 2 times 1. So notice how these values cancel out. We're dividing. And really, it's just 5 times 4, which is 20. So in this case, there would be 20 ways of making the groups. Versus the combination, the order does not matter. So it's not specific. You're just making the groups. So that is a combination. How many combinations can we make where order doesn't matter? So here, this would be 4 factorial, because that's your total number of total number of items, over, again, subtract. So 4 minus 3 factorial. But then we're going to multiply that by 3 factorial, the number in each group. So to solve this, this would be 4 factorial divided by, well, that's just 1 factorial, and technically 1 factorial is just 1. So here, and then times 3 factorial. So this is 4 times 3 times 2 times 1 over 1. So, I mean, that's just 1. And then 3 times 2 times 1. So notice we're dividing out 6, and really there are just 4 different ways of making these groups here. So we're just going to first focus on the problems that involve like what we call fundamental counting principle or factorial. So like here, you're at a taco bar. There are 3 options for the type of shell, 4 options. for the type of filling and 6 options for the topping. So how many different tacos can you make? So fundamental counting principle literally just states you take the amount from each situation and multiply. That's it. So how many different types of tacos can we make? There were 3 times 4 times 6. So there are 72 different tacos that can be made. Now in 1B, how many ways can the letters in math be arranged in a 4-letter string? And letters cannot repeat. So math, well, there are 4 different ways, right? So like if you think about it, how many different letters are there for the first? There are 4. Then this is a 4 factorial because you have 4, right? But then letters can't repeat. So then how many letters are left to choose from for the second letter? 3. How many for the third? 2. How many for the last? There's only 1. So notice that's why this is your factorial, because the letters cannot repeat. So 4 times 3 times 2 times 1. So there are 24 different ways. Now here with the license plates in Georgia, 3 letters and 4 numbers. So there are 26 letters, and then this is like digits, which there are 10 digits because you have 0 to 9. So there are technically 10 digits here, 0 to 9. Each letter and number can repeat. So how many different license plates can there be? So here we go. We're going to start off with our 3 letters, right? So how many different options are there for the first letter? The 26. How many different options are there for the second letter? 26, because they can repeat. How many options are there for the third letter? 26. So then here, how many options are there now for the first number? 10. How many options for the second? 10. Third is 10, fourth is 10, and multiply. So notice, guys, another way, if you wanted to write this out, this is 26 to the third power times 10 to the fourth power. So that means here you have 175,760,000 different license plates. Versus in Florida, same thing, 3 letters and 4 numbers, but now they cannot repeat. So 3 letters. So how many options are there for the first letter? 26. But now how many for the second? 25. It's like our dependent situations, right? How many for the third? 24. But then the numbers, right? How many numbers? 10. But then because they cannot repeat, how many numbers now for the second one? 9, 8, and 7. So now notice here the difference, right, between that repeat and cannot repeat. So there are 78,624,000 different license plates that can be made. So go ahead and pause the video and just try these 3 on your own before I go over them. And here we go. So here you have 5 pants, 8 shirts, 3 ties. So how many different outfits can be made? So here's your fundamental counting principle. 5 times 8 times 3. So there are 120 different outfits that can be made. Now here you have a 4-digit passcode, but the digits cannot repeat. So how many options are there? So you have 4 digits, right? How many options are there for the first digit? Well, there's 10, but because they can't repeat, there are 9 for the second, 8 for the third, 7 for the fourth. So there are 5,040 different ways that a 4-digit passcode can be made on a phone. Then the lottery ticket. You pick 3 numbers, 0 to 39. So there are 40 numbers, but numbers can be repeated. How many different ways can a lottery ticket in this case be made? So again, if you're choosing 3 numbers, right? How many options for the first? 40. How many options for the second? 40, and third is 40, because now they can be repeated. Or this is 40 to the third power, right? And you get 64,000 different ways that this lottery ticket can be made. If you think about it, what is the probability of winning a lottery in this case? 1 out of 64,000 chance, right? Because there's only one winning ticket. Ooh, sorry, hold on. I think, oh, yeah, there we go. I realized. Sorry about that. I need to fix that. There we go. Okay. So now getting into the permutations and combinations. So now it's like, here's this amount and what is the amount of groupings that can be made. So we actually started already some of the permutations and combinations in the previous problems. But these two are up top so that you see the difference between a permutation and a combination. So here, how many ways can you choose a president, vice president, and secretary out of 18 people? Notice how specific this is. Versus how many ways can 3 people form, oop, that's a typo, sorry, form a group out of the 18 people. So notice you're just making groups. How many combinations? So this is your combination. This is the 18C3 versus this is very specific. Out of the group of 18 people, how many ways can you choose? A president, a vice president, a secretary. That is your permutation because this is very specific. This is your 18 permutation 3. So you could solve this just like what we did before, where how many ways are there of getting a president? 18, then 17, then 16, right? Because a person can't be a president and vice president and secretary. So you can't have that. So again, just to show though the setup, this would be 18 factorial over 18 minus 3 factorial, which is 18 times 17 times 16, right? So I'm just going to times 15, but I'm going to stop here. I'm not going to go all the way to 1. I'll stop at 15 factorial because then in the bottom you have 18 minus 3, which is 15 factorial. So again, notice the 15 factorial divided by 15 factorial is 1. So there it is, 18 times 17 times 16. So there are 4,896 ways that you can create or choose those 3 people versus just how many groups can there be made. So this is your 18 factorial over. Remember again, right? You're going to subtract 18 minus 3 factorial. But now multiply this by the 3 factorial. So how the groupings. So this is a little different, but again, this is 18 factorial divided by 15 factorial, but also times 3 factorial. So we're still going 18 times 17 times 16 times 15 factorial, right? Because then this is 15 factorial times, sorry, there we go. Oh gosh, it was being a little slow there, times 3 factorial. And then the 15 factorial divided by 15 factorial is 1. So now notice the difference. We're getting this 4,896, but you still have to divide it by 3 factorial, which is 3 times 2 times 1. Or really, if you notice, that's just 6. So that's why in this case, there are 816 groups that can be made out of the 18 people. So here, the first one, 2A. You have 30 classmates, so there's our total, right? Like that's the N. And how many ways can you choose 4 to be your group mates? Well, there's nothing specific about this, right? So is this a combination or a permutation? A combination. You're just making the groups. So this would be 30 combinations with your 4 here. So you've got 30 factorial divided by, subtract 30 minus 4 factorial. But because it's the combination, don't forget to also multiply by 4 factorial. So this is If you notice, right, 30 factorial divided by 26 factorial, right, from 30 minus 4 times 4 factorial. So now when you solve, you have 30 times 29 times 28 times 27, but then times 26 factorial, right? Because then you're dividing by 26 factorial times 4 factorial. 26 factorial divided by 26 factorial. So really you've got these values here, but you're dividing by 4 factorial. 4 times 3 times 2 times 1. And that's here, practicing if you need to, right? Putting in the calculator. There are 27,000, though, 405 different groups that can be made. So then in 2B, there are 8 people competing in a race. So there's your total. How many different ways can first, second, third place medals be rewarded? So now notice, is this the combination or permutation? A permutation. So this is a permutation because now you're specific, right? So again, you could set it up, the permutation. So 8 permutations, and then we have 3 here, right, first, second, third. So you have 8 factorial over 8 minus 3 factorial. Or this is 8 factorial divided by 5 factorial. So in the end, just like before, if you wanted to solve it like how we also did it, this is just 8 times 7 times 6, because now the order matters. And you'll get the same thing here, right, when canceling out. And there are 336 different ways. So then 2C, the Sunday shop. 2 layers, 4 layers, 5 layers. The shop carries 65. So there's our total, right? 65 flavors. How many different 4-layer sundaes could you create without repeating toppings? So there are 4 layers. So again, but here's the key. This is without repeating flavors. So because this is without repeating flavors, then this is a permutation because now you can't repeat. So again, this is 65 and then permutations of 4 here, right? So 4 layers. Or again, this is 65 factorial over 65 minus 4 factorial or 61 factorial, which is 65 times 64 times 63 times 62, right? Because this is without repeating. So go ahead and pause the video now and try these U tries on your own. So here in the first one, you should have seen that this is just creating out of the 12, just 3 topping pizza. That's it. So this is a combination problem. So you had the 12, but then 3 here. So you should have gotten 220 different ways. Then here, 10 members, how many 6-member committees? Again, nothing specific. This is a combination. So here you end up with 210, because this again is 10 and then combinations of 6. Now 2C, 7 speed skaters, but how many different ways could the gold, silver, and bronze? So notice now the order matters. So this is your permutation. This is your permutation here. And there are 210 different ways that they could finish. So there are the practice problems. Now, I am just going to quickly go through here if you would like to know what the answers are. But again, pause the video, try these 6 problems. Now, number 5, that I would say is your double starred because I want to see how you would set up if you want to. Of course, I'll still go over it, this probability question. But go ahead and pause the video and try these out fully on your own. All right. So here for the first problem, you should have noticed that this is like our permutations, because here you have 10 total digits, 3-digit code, and no digits can be repeated. So this is just like a good old 10 times 9 times 8. So 720 different 3-digit codes. Then here, 13 total members. You're selecting 3, but here they're specific: president, vice president, and secretary. So this is again a permutation, and you should have gotten 1,716 different possible ways. Then here, 7 websites. How many different ways can he list the websites? So again, that means that none of them can be repeated. You're not talking about groupings. So this one was a good old 7 factorial, 7 times 6 times 5, all the way down to 1. There are 5,040 different ways that he can list the websites. Then here, there are 28 songs on his computer. How many different 8-song sets can he choose? So again, you're just making groupings. So this is a combination. So here you should have gotten out of your combinations 3,108,105. I'm going to skip 5 to go on to 6. So just in case if those who did not do 5, I'll go back to it. You have 8 dogs, groups of 2. That's it. So this is groups, combination. So how many combinations? There are 28 different ways. That's what you should have gotten here with your combination. So now number 5. Here is just talking about, they're just saying consider this number, right? But we're only focusing on creating 3 digits. What is the probability of making a 3-digit number whose value is greater than 700? So first off, how many total different 3-digit numbers can be made? Well, if you think about it, digits can be repeated, right? So here, a 3-digit number. That means, though, here's what's tricky about this. A 3-digit number, how many digits are there? There's actually 9. Because can you have 0 as the first digit for a 3-digit number? No. When you get to a 3-digit number, you're now starting in the 100s. So this is 1 to 9. That's what's tricky about this one. Then how many digits are there for the second? 10, because there's 0 to 9 times 10. So notice there are 900 different ways of making a 3-digit number. Now, you've got for the numerator, but it has to be greater than 700. So here, how many different ways can you make a 3-digit number greater than 700? Well, first off, what digits could the first be? Well, it could be 7, 8, or 9, because technically 701 is greater than this. So here, there are 3 different digits. Then how many for 7 to 9? So then how many digits could be here? 10, 0 to 9, right? Because this could be, like what we just said, right? 701. Then that means how many digits are here? 1 to 9, right? Because you can't have 0 because then it's not greater. So times 9. So there are 270 different ways of making a number greater than 700. So that is your probability, which simplifies to 3 out of 10.